Welcome and thank you for joining. In this lesson, we'll explore simplifying polynomials. This is review from grade 10 and is one of the first lessons in the grade 11 math course. So our focus will be on multiplication, polynomial with a polynomial, and bringing polynomials to the power of 2. So the strategies that we'll need to keep in mind are, remember that a polynomial multiplied by a monomial, we use distributive property. When you multiply two binomials, we use a distributive property that in the past we've called FOIL, so first, outside, inside, last. We'll talk more about it as we look into the examples. And to multiply any two polynomials, you take the term of one of the polynomials and then you multiply by each term of the other, and then you continue with the second term and multiply by the polynomial and so on. So let's explain this through the examples. So in the first example, what we have is multiplication of number 3 with x minus 4 and x plus 2. And then we have to subtract in here the product of 2 with x plus 5 and x minus 3. So I'm going to group them together so that we can better see what we are multiplying with what and not mix them up. I've seen people do very interesting things, such as taking this number here and multiplying with the numbers at the end of the expression. Remember that you have a subtraction in here, right? That doesn't allow you to multiply by this number, the entire thing there. So I want us to focus on this part of the expression. So as you can see, you have three things multiplied with each other. So a monomial with these, and binomial and another binomial. Now the order in which we multiply terms or expressions doesn't really matter. So recall that if you have 2 times 3 times 4 is the same as 3 times 4 times 2. So it doesn't really matter in which order we choose to multiply, but there is always one more practical way than the other. And what I would suggest we do is we multiply the binomials first. And that is because when you multiply by the monomial, you're making this binomial a little bit more complicated and then multiplying with a complicated thing, which is another binomial. So it's not a must, but I think it's definitely preferred. And from experience, I think it leads to fewer opportunities to make errors. So I'm going to start off with FOIL, so first terms in here, so that will give me x squared. And then outside terms, so x and 2, so that will give me 2x. And then the inside terms, so negative 4x. And the last terms in here. There goes our FOIL. And next we have minus 2. We'll do the same thing in here. So we'll multiply x squared minus 3x plus 5x and then minus 15. Obviously, here we have a little bit of work to do inside brackets. So we have to simplify. And then we have minus 2x squared plus 2x minus 15. So next we'll multiply number 3 now by what we got from the binomial multiplication. So again, 3x squared, number 3 is multiplying every term in the trinomial. So negative 6x and then negative 24 here. Remember that number 3 is not multiplying only the first terms. Every term in here has a factor of 3. That's why 3 is sitting outside. And now in the same way, we have negative 2 multiplying x squared. So that's negative 2x squared. Negative 2 multiplying 2x, negative 4x. And negative 2 times negative 15 is positive 30. So lastly, we will 3x squared collect like terms, minus 2x squared. These are like terms. And then we have negative 6 and negative 4. So negative 6x minus 4x and negative 24 and 30 are alike. And lastly, we will simplify. So negative 3, oopsie. So negative 3 minus 2, that's 1x squared. And then minus 10x and then plus 6, and that's a final answer. So I encourage you to write the steps the way that you see them better. So, or simply write notes or things that you want to remember or are memorable to you, or things that, you think will help you with the future examples or questions. So what I would write in this case is expand and multiply first. So you can use these two words interchangeably here. It's the same thing. So if you want to write a note about multiplying binomials first, so or multiply bigger expressions first, that would be totally appropriate. Okay, expressions, and then the smaller ones. And then the rest is collect like terms and simplify. And simplify. So in the next example, we have the product of two trinomials. So since we have the product of two trinomials, now we don't have FOIL, exactly FOIL, but we have something that looks like FOIL. So we're going to take x squared and multiply it by every term in the trinomial here. So x squared times 6x squared, 12x to the power of 4. X squared times x is x power 3. And x squared times negative 2x squared. Next, we have the term negative 3x. Negative 3x will multiply every term in the second trinomial. So negative 18x to the power 3, negative 3x to the power of 2, and positive 6x. Lastly, we will have negative 1 multiplying every term in the trinomial. So negative 6x squared, negative x, and then plus 2. So this is an expanded expression, and we'll continue now with grouping like terms. So I will start by highlighting them. I see that 12x4 doesn't have any friends, so we're going to leave it as is. And we have the x cubed terms, so we have two of them. So we have plus x cubed minus 18x cubed. Next, we have x squared terms. So we have 3x squared terms. So negative 2x squared minus 3x squared minus 6x squared. And lastly, we have so we have x terms, negative 6 and negative 1x. And really, lastly, we have the constant term, which is the number 2 at the end. Now that we have grouped like terms, we're very close to the final answer, and we're going to write 12x4 as is. So these two, 1 minus 18 is minus 17x to the power of 3. We have negative 2 minus 3 minus 6, so that would make negative 5, negative 11, x squared, negative 6 minus x, negative 7x, and then plus 2, and that would be the last step. So again, the steps are the same. So you expand. The way you expand is slightly different depending on what you are multiplying. So every term in the first polynomial, multiply each term in the second. So every term in the first multiplies every term in the second polynomial. That's what we mean by the second. And then we group like terms, and lastly we simplify. Let's move on to our next example. So this time we have a polynomial brought to the power of 2. Now you probably remember the formulas a plus b squared, so that was easy to kind of remember and apply directly. But this is not an a plus b, so it's not 2 terms, it's 3 terms, so we have to take our time in here. And we'll rewrite this expression as x squared minus 2x plus 5 multiplied by x squared minus 2x plus 5. So there is no formula for this. So we have x squared times x squared, so it's the same strategy. We have x to the power 4, and then we have negative 2x to the power of 3. I'm going to remove these lines because they kind of look a little bit awkward. X squared times 5 is 5x squared. Now we have negative 2x, that is multiplying x squared, negative 2x cubed, negative 2x times negative 2x, that will make positive 4x squared, and then negative 10x. That goes for these two. Now we're going to do 5 multiplying every term here. So we have plus 5x squared minus 10x plus 25. So just to make it a little bit clearer for us and to remember, so we have these 3 terms that come from multiplication with x squared. We have multiplication by negative 2x. We got these terms in here. And multiplication of number 5 by the expression, the second polynomial there would be here. And now we are going to group like terms. So we have x to the power 4 on its own. We have x cubed, negative 2x cubed, only 2x cubed terms, so that would make negative 4x to the power 3. And again, as you become more experienced at this, like you don't want to take the grouping the like terms as a single step. And then we have 5x squared and a 4x squared, another 5x squared. So it seems that we have 5 plus 4, 9 plus 5, 14, x to the power of 2. Now we're looking into the x terms, so we have to move down in the expression, and we have negative 10x minus 10x, that's negative 20x, and then the constant term, which is 25. So again, you expand, meaning that you turn the power into a product because you want to see where the terms are and how to multiply. And in the next step, then you kind of collect like terms. And last step would be to simplify. Simplify. And you're done. Now let's take a look at a couple more examples. So we have a bigger expressions. In principle, we are doing the exact same thing. So again, always examine the expression first so that you know who is multiplying what. So these are multiplying each other. These are multiplying each other here. And lastly, we have this expression down here. So let's get to work. So we are going to multiply 2x by x to x squared. And then 2x by negative y, negative 2xy. And then we have 3yx or 3xy to keep things in order, and minus 3y squared. So that would be what we get from the yellow product. Now we're going to do the pink product. We have a little bit of work to do in here because we have minus 4 and then we have this to the power of 2. Now I'm going to write out the expression or the formula a minus b squared. Remember, is the first term squared minus twice the product of the first and the second, and then plus b squared, so the second squared. So we have x squared minus, we have double of x with negative 2y, so that would make it negative 4xy. And then lastly, we have 2y squared, which is 4y squared. So remember, number 4 is still sitting here. We haven't finished up multiplying in here. We need multiple steps. And lastly, we have a simple expansion, 5x squared minus 5y squared. So now we're going to try to simplify as much as we can. So negative 2xy and positive 3xy will make 1xy. So we'll simplify that, why not? And now it's time for us to expand in here. So please expand by multiplying by negative 4 every single term. So negative 4x squared. Now positive 16xy. And then negative 16y squared. And then plus 5x squared minus 5y squared. So we're going to group like terms, and I'm going to take this as a separate step because it seems that we have quite a few different terms. So I'm going to start with x squared terms first. And I see that I have 2x squared and negative 4x squared and a positive 5x squared. So if you highlight them, and you can trace them down very easily. I'm just going to write the steps this time, but again, something to consider. And now we're going to do the xy terms. So we have an xy and a 16xy, and that's it. So plus xy plus 16xy. And now we have lastly the y squared terms, and we have 3 of them. So negative 3y squared minus 16y squared minus 5y squared. We are on our last step. So we have negative 2x squared, plus 5x squared. We have 3x to the power of 2. And we have 1xy and 16xy, so that would be 17xy. And lastly, negative 3 minus 16 minus 5, so that will make negative 19, negative 24y squared. And this would be our final answer. So the next example is for you to try on your own. So I'll continue it here, but feel free to practice this on your own. Now here what you see is different sets of brackets. And we have to examine again what's multiplying what. And remember that round brackets are the higher priority kind of brackets. So I see that 3x minus 5 is multiplying the entire red bracket. I mean the square brackets in here. I was planning to make them red, that's why. And what we're going to do is we're going to clean up this expression in here. So what we have is the number 3. And we're going to write this. I'm going to make sure it sits here lonely on its own. I've seen very often people take this number 3 and multiply by everything in here. You have addition, so 3 has no business multiplying anything, so it's on its own. The only thing we'll multiply here is these two binomials. So we have 2x squared minus 2x plus 4x minus 4. And we're going to close those square brackets. Remember where these come from, right? So negative 2x, and then positive 4x, and then negative 4. Now, before we start expanding, you see that we have the multiplication of 3x minus 5 with this set of brackets, so we will have to simplify the square brackets. And square brackets, we can make them round now because we don't have double brackets in there. We have the 2x squared term. We have negative 2 plus 4, which is a 2x, and then negative 4 plus 3 is minus 1. Close the brackets. So as you can see now, we have multiplication of a binomial with a trinomial. So simply take the first term and multiply it by every term in the trinomial. And then take the second term and multiply by every term in the trinomial. So we'll do just that. And I'm going to keep this blue. I'm going to start off with the term 3x. And we're going to say that we have 6x to the power of 3 plus 6x to the power of 2 minus 3x. We all see where this comes from, right? So 6x cubed, 6x squared minus 3x. And then next we will multiply negative 5 by negative 5. Let me highlight it. I think that's easier. So we have negative 5 multiplying every term in the trinomial. So negative 5 times 2x, negative 10x to the power of 2. So negative 5 times 2x squared. And then negative 5 times 2x is negative 10x. And negative 5 times negative 1 is positive 5. And that's what we get from this product in here. We can group like terms. So we have 6x to the power of 3. And then we have the x squared term, 6x squared minus 10x squared. And then we have the x terms, negative 3x minus 10x. And lastly, we have the constant. Last step, we simplify. So we have 6x cubed minus 4x squared minus 13x, and then plus 5. That would be the final answer. Now, lastly, we have example number 4, where we have also a word problem or an application. And this is slightly different. So we're going to do this together. We have to expand and simplify. It's an example that involves fractions. Fractions are just expressions, right? So nothing to worry about. Just follow the rules as you know them, as you've done them in the previous easier examples, and you'll see everything will work out. So work slowly and confidently, in other words. Now, I don't know if you notice right away, but I invite you to take a look at this expression in general, look for patterns. So you see that you have 2 over x in here, 2 over x in here, 3x, 3x, and the signs are different. And this probably reminds you of this special formula, a plus b, a minus b, the special product, which we call difference of squares because the answer is actually the difference of 2 squared terms. So if you recognize the formula, the expansion will be quite easy. All you have to do is bring 2 over x to the power of 2, and then 3x to the power of 2, and the sign in between will be a minus, so this minus in here. And in a more simplified form, this will turn to 4 over x squared minus 9x squared. And this is a good enough way of expanding this. But in case you forgot the formula, you simply will have to perform the multiplication the FOIL way. So that's the answer. Now you can try this. So in the next example, you have something similar, not exactly the same, but again, you can probably recognize the product a minus b, a minus b. So this is a perfect square trinomial. So this is the same as a minus b brought to the power of 2 gives a squared minus 2ab plus b squared. So what that means is that this is going to be our a term, and this is going to be our b term. And we have x squared to the power of 2, the a term, minus twice the product of x squared with 5 over x, and then plus 5 over x to the power of 2. So I simply apply this formula, and now we have x to the power 4 minus, careful here, you can simplify. X squared and x will simplify to x minus 10x, and then plus 25 over x to the power of 2, and this would be the final answer. Let's take a look at our last example. We want to write an algebraic expression for the shaded area. As you can see in here, the shaded area is made of this rectangle from where we remove the areas of these white triangles. So we're going to write in here that area shaded is equal to the area of rectangle ABCD, and then take away the area of the triangle. Just gonna name it as EBF. And then take away the area of the triangle FGC. So let's see what we are given here. This is not the only way to approach this problem, but I would say that that is probably the more practical way. So when you look at the entire rectangle, you see that it has the length of 3x minus 3 times x plus 1. So remember, that's length times width. So the length here would be 3x minus 3 plus x plus 1. The way I know it is because the length is BF plus FC. And that will simplify to 4x minus 2. The width, on the other hand, is given to be x plus 2. So we're going to write that the shaded area would be x plus 2 multiplied by 4x minus 2. Now we're going to remove the area of this triangle, which is going to be 1/2 of the base with the height. So 1/2 of 3x minus 3 multiplied by the height, which is x plus 2. And lastly, we'll remove the area of this smaller triangle here with the base x plus 1 and a height of x. So 1/2 of x plus 1 times x. So we have quite an expression to simplify in here. So it is long, it's not difficult. Always keep that in mind whenever you feel a little bit intimidated by the size of a problem. So we'll take things one at a time. So we are multiplying these two to get the area of the rectangle, and then we're multiplying these three things, and then that's these ones. And then here we're subtracting. Now, x plus 2 4x minus 4, that's FOIL, so 4x squared minus 2x plus 8x minus 4. So you see where we're going with this. So minus 1 over 2, so we're going to do binomials first, that's what we've said. And we have 3x squared plus 6x minus 3x minus 6. And then minus 1 over 2, x squared plus x. If you multiply this. And let's continue simplifying as much as possible. 4x squared plus 6x minus 4. Now we have minus 1 over 2, 3x squared plus 3x minus 6. We're doing brackets first. And then minus 1/2 of x squared minus x over 2, or 1/2 of x. So let me write them in the same format so we are consistent. Okay, so now we have again 4x squared. I am going to add one more page here, I'm afraid. I have 6x minus 4 minus 3 over 2x squared. So again, see we are multiplying here. And then minus 3 over 2x, and then plus, remember, negative half, negative 6 will give 3. Half of 6 is 3, and both negatives. Negative or minus 1 over 2x squared minus 1 over 2x. So we're going to group the like terms. So we have these 4x squared and negative 3 over 2x squared. More x squares? Yes, right here. So we'll rewrite them as 4x squared minus 3 over 2x squared minus 1 over 2x squared. So what do we have next? So next we have 6x, so the x terms, negative 3 over 2 and negative 1 over 2. So 6x minus 3 over 2x minus 1 over 2x. And lastly, we have the constant terms, and we have negative 4 and positive 3 in our case. So negative 4 plus 3. So let's take a look at this. So we have 4 minus 1.5 minus 1/2. That will make 2x squared. Now 6 minus 1.5 minus half, that's like 6, 1.5 and a half here will make 2 negatives, so 4x. And negative 4 plus 3 is negative 1, and that would be the shaded area. So we're going to say that, therefore, the shaded area is 2x squared plus 4x minus 1. And we're going to write unit square in here because we're not given the exact units that we're using. So this was the lesson 2 with focus on reviewing from grade 10. And thank you for learning with me again, and bye for now.